Hello, we are Team HBNUE and we will be presenting on defining pseudo labels for robust test time adaptation. Our method consists of the teacher and student models. The teacher model outputs pseudo labels using augmentation averaged pseudo labels. The student model incorporates a parallel 3x3 convolution layer alongside the classifier block and exclusively train the 3x3 convolution layer. To provide more accurate pseudo labels to the student model, we introduce two methods. First, we examine all pseudo labels within a designed range of epoch, and if any inconsistencies are detected within this range, they are excluded. Second, we adopt pseudo label uncertainty estimation. Specifically, pseudo labels with low entropy are considered to be more reliable. However, inaccurate pseudo labels still exist. To prevent the model from overly relying on incorrect pseudo label during adaptation, we adopt diversity regularization. Additionally, since we use models pre-trained on ImageNet, it makes prediction for unnecessary clashes. The prediction is filtered to calculate the loss only for those corresponding to the clashes present in dataset. Through the method mentioned above, we obtain more accurate pseudo labels and reduce the influence of inaccurate labels even if they are used. Therefore, we can utilize the supervised contrastive loss guided by accurate pseudo labels. When utilizing pseudo labels, performance increased by 6.25%. Applying the pseudo labeling scheme resulted in an accuracy increase of 0.3%, with an additional 0.2% improvement achieved without diversity regularization. Furthermore, integrating class masking led to a notable performance enhancement of 0.45%. Finally, employing the supervised contrastive loss led to a performance increase of 0.15%. Our main ideas are the 3x3 convolution layer and the pseudo labeling scheme. The source of our idea are indicated in the notation. By adding the 3x3 convolution layer, we aim to run out of distribution inspired by approach introduced in the reference paper to handle the unseen noise. The pseudo labeling scheme draws inspiration from the annotation, where the past pseudo labels are observed to form negative pair for contrastive loss calculation. The following graph compares the performance of previous method by varying the pre-trained models. As can be seen, the performance ranking changes significantly depending on the pre-trained model used. In the future, test time adaptation method should be robust, regardless of the pre-trained model they are applied to. Thank you for listening.